What are forced oscillations? As I mentioned, a forced oscillation involves an external force that, with a particular frequency, is applied to a system that would naturally oscillate even in the absence of that force. If we look at the answer for this, we're going to see some of the mathematical details. In particular, it adds a driving force that has a time dependence that is harmonic. And in this case, I used a cosine for that. One could use sine as well. But this additional force is there, and it's actually added to the model that we already had for damped oscillations. So if you analyze that with Newton's second law, you wind up getting that driving force. You wind up having a spring type of force because our simplest model really for oscillations in nature is based on the mass oscillating on a spring example. And then we have the damping force that we looked at in the previous topic. And then this is a differential equation that can be solved. And it turns out the steady state solution with no transients is stated here, which is basically harmonic motion. There is a phase in it that winds up depending in a pretty complicated way on some of the details. In fact, that's shown here. It's related. The tangent of that phase is related to some of the other parameters. I don't think everything is being shown here though, because like omega naught, for example, is still following the definition to be square root of k over m. That's something we saw briefly in the previous topic. This omega d, of course, is the driving frequency. So in that sense, there's really two frequencies in this system. There's omega naught that represents the natural frequency at which the mass on the spring would oscillate, but there's the driving frequency of the force that is applied. And those don't necessarily have to be equal to each other. They could, of course, be equal to each other. You could say, hey, I'm going to drive the system at a frequency equal to what is natural to it, and then see what happens. Part of this solution, though, is this complicated formula we saw on the key concept slide for the amplitude of this oscillation, which depends on the driving frequency. And we'll see that it tends to be large when that driving frequency is close to the natural frequency for the system.